Welcome back to GATEX AIML. Today we'll solve few more problems in probability theory, conditional probability and Bayes theorem, and then conclude this chapter. In the next video we'll start with the next chapter, that is random variables. So let's solve this problem. A box contains 4 red and 6 black balls. 2 balls are drawn at random without replacement. This is very important, okay? Without replacement. What is the probability that both are red? They are drawn at random without replacement. 2 balls are taken simultaneously. Now, what is the probability that both are red? Okay, we're saying what is the probability that both are red. So, denominator, how many possible combinations are the total outcomes? So, out of 10 balls, I have to choose 2 balls. Now, both should be red. So, I have to choose from red only, right? 4, 3, 2. This comes out to be, I think, 6 by 45, that is equal to 2 by 15. Okay. Next, the urn contains 5 white, 7 black balls. 2 balls are drawn one after the other. 2 balls are drawn one after the other with replacement. See, first one ball is drawn, again it is put back. One more ball is drawn, again it is put back. So this is with replacement. Be careful. So when it is with replacement, it becomes a simple probability problem. What is the probability that both balls are black? Now, what is the probability of choosing a black ball? The first, when I draw first, I have to choose 7 out of 12, that is 7 black balls. So probability is out of 12 balls, 7 are black, into, that is the first draw. And now the balls are again put back. So whatever ball I have drawn, again put back. So again there will be 12 balls remaining. Again I have to draw a black ball. What is the probability? Again it is 7, because I have put back that ball. Okay. So the answer is 49 by 144. Next, in a class of 30 students, 18 like mathematics. So let's mathematics equal to 18, physics equal to 12, and physics and 8 like both. 8 means M intersection P, like both. Now, what is the probability that a randomly selected student likes at least one of the 2 subjects? So basically they are saying the student should like one of the subject, at least one of the 2 subjects. See, when he chooses one subject, definitely there will be one subject. So if he chooses 2 subjects, there will be one subject. What is the probability they are asking? So just find M union N, right? This contains what? P of M, okay, or P of N. So at least one of the 2 subjects is present, right? This or this is present. So repeated case, to subtract them. So this comes out to be, so mathematics is 18 by 30, because I'm taking probability here, okay, plus, then physics is P. Then physics is 12 divided by 30 minus intersection is 8 by 30. So that is equal to, so 30 minus 8, 22 by 30. That is 11 by 15. Next, a card is drawn from a pack of 52 cards. What is the probability that it is either a king or a heart? See, there are 13 hearts, spades, okay, clubs, and 13 more, some other, right? Yesterday I have seen this. 13 hearts in each of these categories, 4 categories, okay, have one king each, one king each. Now they are asking what is the probability the king or a heart. So it is probability of king or a heart. This is equal to probability of king plus probability of heart minus probability of k intersection h. Okay. What is the probability of king? The probability of king is 4 by 52, right? Plus probability of heart. How many hearts are there? 13 hearts are there. This is 13 by 52 minus how many are repeated, that is intersection, both king and heart. So king and heart is only one, no? This one king is in this 13 hearts. So this is 1 out of 52. So this comes out to be 4 by 13. Next, a bag contains 3 red, 5 green and 2 blue balls. 3 balls are drawn without replacement. Without replacement. So it's a combination problem. What is the probability that all are of different colors? Probability that all are of different colors. How will you do this? This is nothing but what? So 3 balls I have to choose. So out of how many? 10 balls. 10 C3. So all different colors, all 3 different means there should be 1 red ball, 3C1 into there should be 1 green ball, is 5C1, and there should be 1 blue ball. So this comes out to be 1 by 4. Next, 2 dice are thrown. What is the probability that the sum is a multiple of 4? So there are 2 dice D1, D2. So it can have 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. Now it should be multiple of 4. Multiple of 4 means what? M is equal to, it can be 4, 8 or 12. 16 is not possible because maximum 6 plus 6 you can get it as 12 only, right? So now find all those combinations which satisfy this condition, divisible by 4 or multiple of 4. So start here from here. 1, 1 is not possible, 1, 2 is not possible. So 1, 3 is one pair. Next, 1, 4 is not possible, 1, 5 no, 1, 6 also no because it becomes 7. Next, 2, 1 not possible, 2, 2 is possible, 2, 2. Then 2, 3 is not possible, 2, 4 no, 2, 5 no, 2, 6 is possible, right? 8, 2, 6. Next, 3, 1 is possible because 3 plus 1 is 4. 3, 2 no, 3, 3 also no, 3, 4, 7, 3, 5, 8. So again it is possible. Next, 3, 6 not possible. 3 done. Next, 4, 4, 1, 4, 2, 4, 3, 4, 4. This is possible. 4, 5 is 9, 4, 6 is 10, not possible. Next, 5. 5, 1, 5, 2, 5, 3. 5, 3 is 8. So this is possible. Next, 5, 4 is 9. 5, 5 is 10. 5, 6 is 11. Okay, then see from the other side. 6, 1 is not possible. 6, 2 is possible. 6, 2. Then 6, 3 not possible. 6, 4 no. 6, 5 is 11. 6, 6 is 12. This is possible. So now it is done. So how many possible combinations are there? 6 square. Outcomes are 6 square. Out of this 9, that is 9 by 36 equal to 1 by 4. Okay. So in a group of 100 people, 60 like tea, coffee equal to 50, and T intersection C is 20. I think similar problem you have solved. What is the probability that a randomly selected person likes tea or coffee? That is P of T union C equal to P of T plus P of T minus P of T intersection C. Okay. You just calculate and check the answer. 3 machines A, B and C produce or if you want me to give the answer should be 0.9. Okay. Next, 3 machines A, B, C produce 20%, 30%, 50% of the items. The total will be 100%. So, it's a conditional probability question. 3 machines A, B, and C. A, B, C. It produces 20% means 0.2. This is 0.3. This is 0.5. A produces 1% defective. D is 0.01. This produces 0.022%. This is 3%. Defective is 0.03. If an item is found to be defective, already saying they are defective, what is the probability that it was produced by machine B? See, I am not taking here non-defective cases because they are also already saying that it is found defective. So it is found defective and it is by machine B. So this is the path I have to select. So I am dealing with this path. So it is 0.02 into 0.3 divided by, all are defective, right? This paths. So total probability rule you have to apply. 0.2 into 0.01 plus 0.3 into 0.02 plus 0.5 into 0.03. So this comes out to be 0.26. Next, a die is rolled twice. Okay. What is the probability that the first roll is greater than the second roll? So this is a roll 1 and roll 2. This should be greater than this. Die contains 1, 2, 3, 4, 5, 6. So if what is I saying? First roll is greater. This should be greater. So if I take 1, I cannot take any number here because 1 is the least among the dice, right? So if it is 2, it can be 1 here. Okay. So it should be 1 here. If it is 3, it has to be what? It can be 1, 2 here. If it is 4, it can be 1, 2, 3 here. If it is 5, it can be 1, 2, 3, 4 here. If it is 6, it can be 1, 2, 3, 4 or 5. Okay. So how many total counts are there? This is 2, 1, that is 1. This is 2, 3, 4 and 5. So add them. So 3 plus 3 is 6, 10, 15. So 15 combinations satisfy this out of 36, right? 6 square. So it comes out to be 5 by 12. Next, A speaks the truth 60% of the time. Okay, probability that A speaks truth is 0.6. Probability that B speaks truth is 0.75 on the time. What is the probability that they contradict each other on a particular fact? Contradict means what? If P says correctly, B will say wrongly, incorrectly. If A says incorrectly, B will say correctly. That is what the contradiction is. So that probability is what? If P of A says the truth, then B has to say it as incorrect. Or if P of B says it correct, then this A has to say it as incorrect. So P of A is 0.6 into 1 minus P of B is 0.25 plus P of B is 0.75 into 1 minus P of A is 0.4. So this comes out to be 0.45. I hope you understood this. Now, 2 cards are drawn from a well shuffled stack of 52 cards. What is the probability that both are aces? Okay, so how many aces are present? You remember our card contents categories. So there are, see, total how many you have to choose? Out of 52, I have to choose 2. So you're choosing it. It's a combination problem. So 52, C2. So how many S's are there? The S's are present in each of the category, 4 categories. Okay. So 4 S's are there. Out of that, you have to choose 2. This is 4C2 divided by 52C2. So the answer is, you can calculate 1 by 221. That's what I'm getting. Next. 3 fair coins are tossed. What is the probability of getting at least 2 heads? Okay, a simple question. Let's take the sample space. All head, head, head. 3 times means head, head, head. Okay. Then head, head, tail. Head, tail, head. So there will be total 2 power 8 combinations, right? So it is like writing your 3 bits 0, 0, 0, 0, 0, 1 like that. Then head, tail, tail. Then tail, head, head. Okay. Next. Okay. These are the 8 combinations. Getting at least 2 heads. This contains at least 2 heads. This 2 heads, 2 heads, 2. Okay. So total 4 by 8, that is 1 by 2. Okay. Next. A committee of 3 is to be formed from 6 men, 4 women. Okay. Find 3. What is the probability that the committee contains at least 1 woman? So you choose at least 1 woman. So you can solve it in by taking at least 1 woman or 1, 2, 3 like that. But we can also do that. So there are all men's. You can do it directly saying that there are only men's. So only men equal to what? If I choose only men, it will be 6C3 divided by 10C3. Now at least 1 woman means what? 1 minus only men's, right? So this is equal to 1 minus 6C3 divided by 10C3. Or also you can do it in another way. How will you do it? So choose 4 women, 4C1 into 6C2 plus like that divided by 10C3. You can do like that, but it is little bit lengthier. Okay. So solve this kind of problems in permutations and combinations, right? Choosing men and women. So this comes out to be 39 5 by 6. Okay. Next. Okay, very simple question. It's been misplaced, I think. 0.5 plus 0.6. This is A union B minus 0.3. This will be 0.8. Okay. Just ignore this. Next. A student answers 5 multiple choice questions. Each question has 4 choices. There are 5 questions. So each question there are 4 options, like your exams. 4 ABCD options. A, B, C, D. The 4 options. What is the probability that exactly 2 answers are correct if she guesses all answers? Okay. She doesn't know any answer, so will she guess all the answers? 5 questions, all 5 questions. She guesses the answers. What is the probability that exactly 2 of them are correct? So how will you solve this? So I have to choose 2 questions which are correct. Okay, exactly 2, 5C2. Then what is the probability that she is correct? The probability that she is correct is what? The probability of getting correct answer is what? Out of 4 options, it is 1 by 4. Now only one answer is correct out of A, B, C, D. Now if she gets it correct, okay, then so exactly 2 answers correct. That means 1 by 4 into 1 by 4, 2. Then the others she should not get correctly, right? How many are other left? So P of incorrect is what? 3 by 4. Now 3 by 4, these are 2 correct answers. Okay, then rest 3 should be wrong. that should answer wrongly. That is probability is 3 by 4. So rest 3 remaining are 3, right? 2 questions answered correctly, 3 questions not correctly. So this comes out to be 0.2637. This is actually the binomial distribution, okay? Example for binomial distribution. We'll see it in binomial distribution again. Next, a lot has 3 defective plus 7 non-defective. This total 10 items are there, bulbs. 2 bulbs are selected at a random. What is the probability that exactly 1 is defective? Exactly 1. So how will you solve this? So total outcomes is 10C2. So exactly 1 is defective means what? I have to choose from this, no? 3C1 into 7C1, because 1 is defective, the other one should not be defective, because I should choose it from this 7. So this comes out to be 7 by 15. Okay. In a certain college, 40% of the students are girls. 70% of the girls study science. Okay, let us. So girls and then boys. So 0.7, sorry, 0.4, 40%, and then 0.6, 60% are boys. Then 70% of the girls study science. Science 0.7. While 50% of the boys study science. A student is selected at a random and is found to be studying science. Already they given the science. Okay. Now, so there are no other paths. There is only one science. There is no maths here or any other subject they have mentioned. So this is the only path. What is the probability the student is a girl? This is the path they are asking. So this is 0.4 into 0.7. Okay. Now, so divided by, out of how many paths? This path and this path. So 0.4 into, this is rule of total probability, plus 0.6 into 0.5. So this comes out to be 0.482. Next, a box contains 10 bulbs, okay, out of which 3 are defective and 7 not defective. 2 bulbs are selected one by one without replacement. Okay, so they are not selected at a time randomly. They are selected one by one without replacement. What is the probability that both are defective? How will you solve this? So first, when the first is taken, what is the probability it is defective? So 3 by 10, right? So there are 3 defective and then there are total 10 bulbs. So I am choosing first one as a defective first. This is not a combination problem, okay? Then second bulb also defective, means the one bulb is already taken out and it is no replacement. So 9 will be left. So how many defective will be left? 2, because one I have already taken here. So 2 by 9 by 90, that is 1 by 15. Okay. Next, a person is known to hit a target 3 times out of 4. That means probability of hit is equal to 3 by 4. Then probability of miss will be equal to 1 by 4, right? 1 minus 3 by 4. What is the probability that he hits the target at least once in 2 attempts? So they are given 2 attempts. So he should hit it at least once in a 2 attempts. So how will you solve this? If I say he misses, okay, he misses all the attempts. So what is the case there if he misses all the attempts? So how will you solve this? Probability of miss is equal to 1 by 4, already know it. Now, he must miss both means what? Or hit at least once means what? At least once means 1 minus, he misses both the attempt, P of miss into P of miss. What it means? 1 minus P of 1 by 4 into 1 by 4, that is 15 by 16. See, what are they saying? Hit at least once means what? If he misses both, okay, missing both, and 1 minus means at least 1, right? So 1 minus missing both, probability of missing both is equal to at least he will be hitting one. That one, at least one will be there. We don't know 1 or 2, at least one he will hit. Next, an exam has 3 sections. The student has a chance, 70% chance of passing section A, 60% chance of B, and 80% for C independently. What is the probability that he passes in at least one section? So, probability that fails in all sections. When you see at least, you should apply the subtraction rule. That is also you are seen in the permutation and combination problems. So whenever you see that at least and all those, you go for the total amount minus the whatever he misses here. Fails in all sections. What is the probability he fails in all sections? So if you pass is 70%, 60% and 80%, it will be, so 100 minus 70, that is 30, is 0.3. This will become 0.4 into 0.8. Okay, then so he pass in at least one, similar to a previous problem. At least one is equal to 1 minus P of fails in all. So this is 1 minus 0.3 into 0.4 into 0.8. This comes out to be 0.976. So that completes your probability theory concepts. So next we'll dwell into most important topic, okay, and interesting topic, that is random variables. From there, actual probability distribution concept starts. Okay, so from here it will be little bit difficult to understand the concepts, but they are very easy. Just try to focus. Okay, so please like, subscribe and share with your friends. From the next class, next video, we'll start with the random variables. Thank you for watching.